Hello everyone, I am Thomas John. Welcome to our new and modern electrical machines lab. So, I am a lecturer in electrical engineering in the engineering department in Edge Hill University. And today I would like you to show demo of one of the experiments we are going to conduct in our new lab. So, this is a converter test bench which consists of different types of converters like AC-DC converter and DC-DC converters. So today I would like you to show an experiment based on a DC to AC converter or an inverter. So if you come closer, you can see that the inverter block is shown here, which consists of 6 semiconductor switches. Now AC supply from the mains is connected here, and that is converted into the DC using a rectifier diode, and then the DC is given to the inverter. Then you get AC at the output of the inverter. Then the three-phase AC output is connected to the RL load here. So using this equipment we can explain the operation of a three-phase inverter. So here I have already given the wirings. Now you can analyze its operation on the PC using a software called LabSoft. So this is the software called the LabSoft, where you can see all the objective, aim, procedure, circuit diagram and connections. So if you open this, you can see the wirings. So based on this, we can connect the wirings. Then procedure is also given here. So it's a very user friendly and convenient tool to do the experiment. Now, following the instructions, I have to do few things. So when I give the settings like this, I will get the output voltages like this. So this square blue wave is actually the output of the inverter, and this red wave shows the current. So this is the output voltage and current of an inverter. So from this you can study the output characteristics of an inverter. So what happens if I change the frequency? So if I reduce the frequency to very low frequency, you can see that the switches alternate in action. So you can see the switching also very clearly. So one by one the switches start flashing. That means the switches are getting switched on alternately like this. So you can study in depth about the inverter and also the switching of each switch here in more detail. So this is one of the interesting experiments we do for the power electronics. Then similarly you can do other experiments using the similar equipment. Now next I would like to show you another experiment. So this is another test bench in which we study the operation of a DC motor. So you know what is a DC motor, right? So this is a DC compound motor. So we can operate this DC motor as a separately excited DC motor. Now here I am going to control its speed using the applied voltage. So as per the circuit diagram, I give the connections like this, and by varying the voltage using the voltage supply, I can make this motor run at the desired speed. So if I enable the power supply, the motor starts running, and then by varying the voltage or by increasing the voltage, I can increase its speed. So that is basically the speed control of the motor. Then also I can understand the procedure, I can tabulate the outputs. So for each voltage, I can plot a graph. So for example, I can plot the speed and the current. So speed is for 220 volts, what's the speed? So I can make the motor run at the rated speed. So rated speed is around 230 volt. So now I am running at the maximum speed. Yeah, so now the input voltage is 220. So what's the speed? It is 2162 RPM. Next, you decrease the speed to 200. What happens? So when you decrease the voltage, the speed also gets decreased. Yeah, so voltage is now 200. What is the speed? 1960 RPM. Now you again reduce the speed, reduce the voltage, sorry. Yeah, so now the input voltage is 180. So what's the speed now? 1767 RPM. Now again you reduce the voltage to say 160. Then the speed is again reduced. Similarly, 140. Speed is now 1367 RPM. Then voltage around 180 or 120. Speed is now 1148 RPM. Now bring the voltage to say 100. Now speed is around 949 rpm. So you can see when the applied voltage gets reduced, the speed also gets reduced in proportion. So from this you can see that the speed is directly proportional to the voltage. So if you want, you can plot this graph now and see. So you can see that the speed is directly proportional to the voltage as shown by a straight line here. So this concludes our experiment on the speed control of a DC motor. So today we saw two different experiments. One is on a converter and one is on a motor. Later I will show you few more experiments, like the one on a microgrid and the other one on a generator. So later I will show you our microgrid test bench, which consists of several equipments like solar, emulator, battery and a hybrid inverter. Then another important experiment is the synchronization of a generator. So using a synchronoscope, I will show you how to synchronize this generator to the incoming supply. So these are the different equipments we have here. So all the different kinds of farm engineering equipments like machines, microgrid, drives and other equipments are available here. So if you are interested, you can come and visit us on open day, and any queries I'll be happy to answer. So I hope you will be motivated and interested to come and study electrical engineering here. So by studying all these different kinds of equipments and microgrid, you will be equipped with new skills and knowledge to work in the renewable energy sector, in the electric vehicle industry and other avenues. So there are a lot of job opportunities available for electrical engineers, and I hope you will be very much interested to study this program in our young department in the University. I welcome you all. Thank you.